Hey guys, trying out a little different spot here. I was gonna try to get Wilson on this one a little bit. He's sleepy. Just went for a morning walk a little bit ago, but he doesn't love people in his business when he's sleeping. So we'll see how long he stays here. Today is that third and final day of solving systems by substitution. So we're looking at another type of substitution problem. In this situation, we're looking where we're going to have to plug directly into the inside of another equation. You'll see what I mean here when we started. I've got two examples for us to look at. This is where the most work is involved, is in these types of substitution problems. So again, just like every other one that we've seen so far, we do luckily, and my touchscreen's pretty glitchy today, so some stuff might start popping up on its own, but we'll make it work. We do, however, still have one of the variables by themselves. As long as that's the case, as long as one of these variables is alone, we're fine. Okay, we would have a way to figure it out even if that wasn't the case, but then it's going to get really tricky. So we do have one of these variables alone. As long as that's the case, substitution is a good route. Okay, so with this y alone, what we're going to have to do today, since y is equal to this entire chunk like we saw last time, we have to now plug it directly in where that y is over here. Okay, you guys were able to plug it into a little bit easier situation where you would have something like y equals blah, 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 and then y equals blah, blah, blah. You had that last time. You were able to just plug it in right where that lonely other y was sitting. In this case, we've got to plug it in where there is a variable in front of it. So we are plugging it in for this y right here. Okay, so since that's the case, there's a situation here that a lot of mistakes are made in. So this second equation, this 4x plus 5y equals 7, is now going to look pretty different. That 4x is still 4x. We're not changing that at all. Okay, but instead of plus 5y, we are saying plus 5 times this entire piece, 2x minus 7. Now, one of the big mistakes that's made is, there's that glitch again. Oh my gosh, equals 7. So with the mistake that's made is a lot of people, when they plug in for this y, they totally forget about the 5 out front. What we end up seeing quite a bit is 4x, and it's going to be really glitchy, 4x plus 2x minus 7. Oh goodness, this is glitchy. Okay. It's being really, oh my goodness. Are you serious right now? Okay. What we see for the mistake a lot is 4x plus 2x minus 7. What people forget to do is that this 5 is still out front of that y. It's still multiplying by this piece that we're substituting. So instead of 5 times y, we're going to have 5 times this entire chunk. This is incorrect because people forget that coefficient of 5. So once we're down here, 4x plus 5 times 2x minus 7, and that whole thing equals 7. Once you're there, again, this is a situation you've done before. Okay, you've done this. We have to distribute the 5 right away because we have to get all that grouping undone. So the 4x is unchanged. 5 times 2x is going to be a positive 10x because they're all positive. And then 5 times a negative 7, when we distribute that 5 to the second piece, is going to be minus 35. So what you should be looking at right now is 4x plus 10x minus 35 equals 7. This is a situation where we're almost done and you've seen multiple times. Combine like terms. 4x plus 10x is going to be 14x. 14x, that minus 35 hasn't gone anywhere, equals 7. Now we're just about done. We're going to add 35 to both sides. You guys are probably starting to see how this is going to finish up now with 2 more steps left. That's gone. Add 35 to both sides. Now I've got 14x equals 42. 7 plus 35 is 42. I'm going to go over here to kind of make this a little bit easier to see. 14x equals 42. And the last step is to divide by 14. And in case you don't know it off the top of your head, use a calculator. You're going to get x equals 3. A lot of work. That feels like a lot of work. Okay? You only have 4 or 5 problems on your homework, so don't freak out about that. So you've got x equals 3. That is the first part of our answer, because remember, our answers need to be these ordered pairs x, y. Okay? Your answers need to be that ordered pair x, y. So we've got x already taken care of. So if you remember what we do here, I'm going to plug this in. You can plug it into either equation, but that one where y is already alone is going to be a little bit easier. There's going to be less work involved. So now instead of 2x minus 7, I'm going to have y equals 2 times 3 minus 7. 2 times 3 is 6. Y equals 6 minus 7. And 6 minus 7 will give me that final y value of y equals negative 1. So now that you've got your x and you've got your y, you have that final answer, ordered pair of 3, negative 1. And that would be your answer on Alex. Quick to show you Desmos again. We've got those two equations. This one, the one in red, is your x, y equals 2x minus 7. The one in blue here that's flashing is your 4x plus 5y equals 7. And that point where they are meeting right here, if I can get it to show, is 3, negative 1. It is exactly what we just found with our work, 3, negative 1. Okay. Wilson appreciates that one, don't you? Okay, good job. All right, so the second example, I'll go through this one a little bit more smoothly here. I've got nice. I've got the second equation equal to just x. So numbers 1, 2, 4, and 5 on your homework will be just like this where your y is alone. And then number 3 on your homework is going to have an x all by itself like this. They don't change at all. It's just a different variable you're going to solve for first. Doesn't matter. It's not going to change what we're doing. So I'm going to plug that 2y minus 8 in for x. So now my new equation up top, this top equation is going to say, instead of negative 3x, it's going to say negative 3 times this entire piece, 2x minus 8, and then plus 4y equals 14. We're going to start moving here to get this one alone. Okay, now we have, oops, excuse me, I made a mistake. Yes, even I make mistakes, as you guys know. This was 2y minus 8, sorry. Now we're going to start distributing this negative 3. So negative 3 times 2y is going to be a negative 6y. Negative 3 times a negative 8 will be positive 24. Don't let those signs get crossed up on you today. And then plus 4y is still hanging out there, and it still equals 14. Okay, now we're going to go ahead and combine our like terms. Negative 6y and positive 4y, since they're on the same side of that equal sign, they're just combining. You're not doing inverse or switching the signs or anything. You're just putting them together the way that they are right now. So negative 6 plus 4y is going to be negative 2y plus 24 equals 14. Now you guys can probably see where we're going to go next. The next step is to subtract 24 from both sides. That's gone. We've now got a negative 2y equals a negative 10. This 14 minus 24 is negative 10. And the last step, divide by negative 2. That's a negative 10. And that's going to cross out to now leave us with y equals a positive 5. Okay, y equals a positive 5. I'm going to move down a little bit for this next step. I'm going to have now, remember, this y, I'm plugging it in right here, so now I can solve for my x. So I've got y equals 5. Now I'm going to have x equals 2 times, instead of 2y, I'm now going to have 2 times 5, and then minus 8. Okay, so this one's a little simple here. We've got x equals 2 times 5 is 10 minus 8. 10 minus 8 is 2. So I've got my x, I've got my y. Okay, I've got my y of my y of 5 up here, my x of 2 right here, and I've got my ordered pair. My ordered pair is going to be 2, 5. Remember, x always comes first. Okay, so these are the two problems that you can check out. You can pause the video on if you want to get a good look at these examples as you're doing your homework. Okay, this is problems 1, 2, 4, and 5. This is just like number 3. Again, the only difference is what variable is alone first. It doesn't matter. Okay, so here's a quick little look at all of it. And that's what you guys have got today. Okay? Wilson, what do you think? Think they can do that? What a lump on a log. All right. See you guys later.